Hello, everyone. Welcome to Ohio Energy Project's Careers in Energy virtual field trip. My name is Kelsey Beach, and I will be your moderator today. Today, we are going to be learning about careers in electrical vehicle manufacturing at Workhorse's manufacturing plant in Union City, Indiana. At this facility, vehicles are tested, designed, and built, and we are going to be lucky enough to hear from the customer success manager, materials manager, and other engineers as they offer insight into the skills that are needed to work in this super exciting field. So before we get started, a few housekeeping items. We want to welcome all of the classrooms that are joining us virtually and go over a few housekeeping items. So if you have questions during our trip, you can post those in the Q&A box via Zoom. If you are joining us on YouTube, there's no live chat. So if you are on YouTube and you want to ask questions, please go back to your registration email and join us via Zoom with the link that was provided there. Along with our classrooms here today, we also want to thank the AEP Foundation for hosting our Careers in Energy program. And a huge thank you to Workhorse Ranch in Union City, Indiana for hosting us on site. Today, like I said, we are going to be hearing from Steve Conrad. He's a customer success manager at Workhorse. We are going to hear from Tony Palmer, a materials manager, Megan Luster, a junior quality engineer, and Josh Thornburg, a manufacturing engineer. Before I introduce Steve, I'd like to read a short biography about Workhorse. So Workhorse is a technology company that's focused on providing drone integrated electric vehicles to the last mile delivery sector. As an American original equipment manufacturer, they design and build high performance battery electric vehicles, including trucks and aircraft. Workhorse develops cloud-based real-time telematics performance monitoring systems that are fully integrated with their vehicles and allow fleet operators to optimize energy and route efficiency. All Workhorse vehicles are designed to make the movement of people and goods more efficient and less harmful to the environment. Engineered with fewer moving parts and durable EV components, Workhorse's line of electric work trucks do more with less mechanical maintenance. 100% battery-powered electric motors mean less noise, zero emissions, and freedom from high fuel costs. Workhorse operates from 4 locations around the United States. Today, we are going to be visiting Union City, Indiana, home of their newly renovated 410,000 square foot facility called The Ranch. The Ranch includes the Customer Experience Center, Battery Warehouse, and Workhorse Factory. So with all that being said, we are going to transition over to Steve Conrad, who we are so excited to have leading us on a tour of the indoor factory today. So we are going to welcome Steve, and we're going to let Steve take it away and introduce us to the facility.
Okay, great. Yeah, my name is Steve Conrad. I'm the customer success manager and head of training for Workhorse, which means I help the end user be successful with their vehicles once they get them. They route selection, charger selection, all those kind of things that you need to successfully operate an electric vehicle, as well as driver training, because there's some quirks to electric vehicles that you need to know in order to be successful when you're operating these things commercially. So my background is actually in education. I've got a master's degree in education. I taught elementary school for 21 years and have been able to successfully manage a shift over to a manufacturing training role here at Workhorse. I've been with the company 7 years, and we are one of the leaders in electric vehicle manufacturing. We've got over 350 trucks on the road with we're closing in on 10 million electric miles. So we've got a lot of experience with our first generation vehicle. And here we're going to look at how we build and develop and put together our next generation vehicle, our flagship W56, and our other bridge vehicle, which we call the W750. So we'll be looking at both of those, talking about some of the background stuff that goes into successfully completing the manufacture of these vehicles.
Awesome. Okay, great. Thank you so much, Steve. So we are going to transition over to the manufacturing area. And while we do that, we have a brief video from Workhorse.
The electric vehicle industry is the way of the future, and we're producing some of the first vehicles that are going to be on the road.
Being a pioneer is going to always keep us ahead of the rest because of the wisdom that we collect along the way.
A lot of what we focus on is how do we provide a product that can compete with the well-developed internal combustion products in the world. We have good leadership that knows the direction that they need to take us in order to succeed.
Our goal is to reduce emissions, increase efficiency, save money for anyone and everyone. It really is about electric vehicles and what they can do for us, what they can do to help the environment, what they can do to help society, and leading that change and leading that charge.
Using technologies which nobody else has used, I think that's one thing that sets us apart. Having a facility that most of the startups don't have, that sets us apart.
The electric vehicles do seem to be where everything is headed. It's fantastic to be at the forefront of that.
Knowing that we're going to be making a difference in the future is incredibly satisfying.
I like the startup feel. There's a lot of young, motivated, smart people here trying to create an exciting product that I believe in.
Everyone here is working toward the same goal. We all want to put out the best vehicle we possibly can.
We have a really great leadership team. We have a great team working on the aircraft every day.
We are listening to our employees. There's not a directive coming down of this is how you're going to do this, and this is the right way to do this, and there's no other way of doing it.
Our leadership structure is just different here, and they actually care about their employees, they care about what happens with the company, and they're actually vested in the company.
The work culture here is amazing. It's not something like I've seen anywhere else that I've worked.
We're very tight-knit, almost like family. We have a very inclusive culture.
Here at Park 42, this brand new facility with tons of space, a new shop, 3D printers, our center fun aisle where we have games and other things for us to let off some steam.
It feels like home. I feel like everybody here works as a team.
That's really why I believe it's built to last, is we have a direction, we have leadership, and we're all starting to march at the same beat.
We're looking into expanding into several markets that are really looking to utilize drones that can help with logistic issues, helping with, say, natural disasters, for example. Just to kind of see where the drones are going to go is going to be really exciting.
Workhorse has the unique combination that you don't see in a lot of startups of having both experience and the young, excited engineers who are ready to put their stamp on the industry.
This is a product that is only growing in demand.
Every day I can say every person is adding some level of value.
Everybody has that drive that they want to get this thing to work, they want to move forward, they want to put the extra time in to move to that next mile delivery.
There are some amazing things going on here. There are, yes.
Okay, great. So that was a super exciting video, and now we're ready to get into the manufacturing area with Steve. So Steve, we are going to follow you around where we're going to look at the manufacturing area and where all of these parts are housed. So take it away, Steve.
Okay, thanks, Kelsey. Yeah, and you heard in that video a lot of people talking about us being a startup, and we're moving towards that manufacturing side of things. And here we are at the start of the W56 build line. You can see our frame here where we align the frame and then put other parts on, some of the frame brackets that give the frame strength. And you can see our tool carts here are all labeled with specifically the tools that we need, nothing really extra, and so that way everybody has the right tools to fit all the different parts, which are clearly labeled on these racks for easy inventory. And there's a lot of people behind the scenes that do these kinds of things. Manufacturing engineers, obviously, for our vehicles, we have mechanical engineers, electrical engineers, software engineers, but then manufacturing engineers who design these systems. So this lift in particular, this is designed to, it's a wheel lift, but we've modified it in another set so that we can actually pick the chassis up. So we build some specific frames, jigs, that kind of thing. This set of frame right here, so we can make sure that all the pieces are aligned properly. A good truck starts with a good frame and aligning all those pieces. Each station has a set of work instructions. So here's station number 2, and you can see that there are tool lists and then the beginning of work instructions here with drawings of all the different parts for that particular station. And so as we progress through the builds, we get more efficient with each one, looking at, you know, what piece is going to go on when. Do we need to design this piece a little differently to make it fit more easily? All those kind of things to be more efficient, not just in the end vehicle, but with our manufacturing. You know, not keeping a lot of inventory. So you can see here's a rack. Any of the orange cables that you see at any point during this field trip are going to be high voltage cables, and you can see they require a lot of different kinds of connectors. So there's a round connector, kind of a square connector there. A lot of times what we'll do is on electrical connectors, we'll make all of them very different, and it implements a philosophy of what's called poka-yoke, which means idiot proof in Japanese. And so you can't plug this connector into the outlet that's supposed to take this particular one. So you know, ease of build right there in the design of the pieces of the vehicle. You know, so we've got high voltage harnesses. Sometimes some of our wiring harnesses are literally just a simple one-piece cable. So once again, the rack, all the part numbers there.
And Steve, as you're moving down the line, we have a question, is there a group that's in charge of each station, as you put it, or do people work on the entirety of a vehicle?
So right now it's groups working on the entirety of the vehicle. When we actually build out the manufacturing system, we'll have some specific, you know, people specifically at station 1, people specifically at station 2. Right now, everybody's kind of working collaboratively to, once again, maximize the efficiency of each one of the stations, you know, bringing their knowledge of, you know, what happened at station 1 forward to station 2, and then moving on to station 3. So that collaborative effort, so everybody going back to the beginning contributes to that maximizing the efficiency of our build process. So, and that, once again, that kind of informs design as well. So the trucks require quite a bit of cooling. So here's some of the larger cooling elements that we have. So when we'll see those later when we look at the chassis, but then, you know, all those cooling things are hooked up to different size hoses. We've got some fairly large coolant hoses that we use because you don't want your electric truck to overheat. Bad things happen when your electric truck overheats. So
great. Okay, and then another question we have, Steve, is what is unique about, you mentioned that Workhorse is a startup company. So what's unique about a startup company in comparison to another company?
Well, so, you know, not to single anybody out, but Ford has been manufacturing vehicles, a massive amount of vehicles for a very long time. So they have a lot of set programs, a lot of things that procedures and policies that they'll follow in their design process, in their manufacturing process, where we are still developing those. You know, we may look at you know, another company and say, okay, that's something we want to take on, something like that, but then adapt it to our own needs. How does that fit what we're doing here? Obviously, the volume of trucks that we're building here isn't going to be anything close to a mass manufacturing plant like a Toyota, but certainly some of those concepts that they use in manufacturing are going to be helpful here. So like for example, parts racks with parts numbers on them, and then all these will have eventually a QR code or some kind of way to scan, say, hey, I need more, you know, for example, this U-bolt, you know, probably some kind of suspension hanger is what it looks like there. So you know, how do we get those parts to the right place at the right time so that our manufacturing process isn't slowed down? We'll come over here. We'll take a look at our one of our W56s. We've got some guys working on it right now, putting stuff together, making sure everything fits. So this is one of our earliest trucks, and so you can see they're working on making sure that the parts that they're putting on here. This is the B pillar of the vehicle, and they're making sure that driver's side B pillar fits onto the vehicle. So obviously there was a designer who said, okay, this is what this part needs to look like. Then an engineer who takes a look at it says, okay, structurally, is it strong enough? Do we need to use a heavier gauge metal? Those kind of things. And then it's sent to a manufacturer who's actually going to build this out of whatever material we specify. Different kinds of materials. We try and use lightweight as much as possible. So the sides of our truck are actually a composite material. 2 people could lift up the entire side of this truck. It's actually very lightweight, but at the same time, it's very strong. It's a foam material with thermoplastic on either side of it. So very, very, very strong material. You can see some of the aluminum extrusions that we're using here as well. So, trying to use as many lightweight materials as we can. Potentially even looking at renewable materials when possible, but trying to maximize the efficiency of our build. Obviously keeping costs down, but at the same time providing a quality product that is going to last a long time. These trucks, we've ridden around with customers and they take a beating, so they have to be substantial. They have to be strong enough to, 15 years down the road, are they still going to be driving around? So,
right.
We need to make sure that they're built.
Is important.
Yeah. Yep.
Awesome. Okay. So Steve, before we move to a finished chassis, is there anything else on the manufacturing area that you'd like to show us before we move on?
Towards the front here, you can see some of the understructure. And once again, this is all engineering. How do these pieces fit together? So, we basically build 2 trucks before we build our finished product. So we have a list of all the materials, all the nuts, bolts, hinges, hose clamps, all that stuff is on a list. The bill of materials, or what we call the BOM. And at the same time, the engineers are building what I jokingly call the cartoon truck, but it's the CAD model of the vehicle. We take those 2, put them together, and we build some of our first vehicles and make sure that all those 3 things match up. And sometimes, this measurement was off by a couple inches, or, we decided to change that, which, this particular piece, which changes that other piece. Mm-hmm. So, as those changes come on, we need to do engineering, design change process that we're working on to make sure that, nothing gets in the way of anything else. So, clearance fits, when the hood comes down, is it going to bump into any of these things? Those kind of thing. Is this bracket strong enough to hold what we need it to hold? If we change headlight design, is this going to work for that? So there's a lot of different, design people that work on these things who are not engineers. They're strictly design, and then engineers who work on strength and durability, those kind of things. And then obviously all the people behind that to buy the parts, purchasing, and then accounting to make sure that those people who have provided us with this or this particular component get paid. And then, people like me who go out to, different truck shows and then, demonstrate the vehicle to our potential customers. So, and then on the other side, we have service people who actually work on the trucks, technicians who, can diagnose if this component goes bad. Is it this component that's a problem, or is it somewhere back downstream that actually is the problem that caused that one to go bad? And the guys who work on these trucks are more technicians than mechanics, really. And that's what we're looking at with moving forward with our service team, is really looking at the diagnostics part of it is the challenging part. The mechanical part is actually, I don't want to say it's pretty easy, but it's really pretty easy. So
Perfect. Thank you so much.
Yep.
Yeah, it's great to hear about all of the different moving parts and how many people are involved in the making of just one truck.
Yeah.
I love these field trips because it just gives so much insight into those details. So, okay, great. So we are going to transition over to Tony Palmer, an interview with Tony Palmer. He's a materials manager at the facility. And then we are going to come back to you, Steve, and check out the finished chassis area.
I'm Tony Palmer. I'm the materials manager at the facility. So my daily schedule is in the morning. I get here and I have an Outlook program that basically gives me tasks and meetings that need to be attended by myself and other people, and it's called Teams meetings. And so I go through that in the morning and then start my daily plan. It involves all the material movement in the plant, outside the plant, and ordering the materials so the plant can run, and scheduling all the production and movements within the plant. So the best part of my job is I get to interact with virtually every department within the plant and create a bond between all of the other facilities and operations within the plant, and it really is a team working environment. So I started out as an assembly worker. I hired in at General Motors, and I was working on the line, and I just progressed to become a supervisor, then went into materials as a supervisor, then got promoted as a general supervisor, and then that's how I went into this environment. So the advice I would give is ask lots of questions, and when you start out learning and absorbing what you have learned and then applying it to your current job, and come in with an open mind and be forced to interject change to make things better.
All right, thank you. We are now going to take a look at the finished truck chassis, and that is the truck frame, and it forms the base for the rest of the vehicle. So Steve is going and walk us through the parts of the chassis.
Okay, yeah, and I'd just like to comment on what Tony said, asking a lot of questions, constantly learning. I went from teaching 4th, 5th, and 6th grade at a Montessori school to doing this. So I had to ask a lot of questions. Fortunately, there were a lot of great people at Workhorse, continue to be a lot of great people at Workhorse who were willing to tell me about things I needed to know to understand my job so that I could help other people understand EVs. So looking at our chassis here, there's a lot of components that are similar on all EVs, just like an internal combustion engine car has a lot of similar components, an engine, transmission, all those kind of things. EVs are the same way. So we'll start at the back here. You can see our frame rails are very strong here, but inside we've got the onboard charger. So when you plug the vehicle in, this is what takes the current off of the wall and converts it into usable current for the battery. So basically converts AC to DC. This is bypassed when you're charging it at when they call what they call fast charging or DC charging. This component isn't used. This is what we call our S box. this is our battery control module. So it anything having to do with the battery's temperature, voltages, currents, any other condition that we might need to look at with our batteries is controlled through this particular component. And this is our high voltage junction box. And here you can see some of those connectors that I was talking about, the different kinds of connectors, different colors of connectors that prevent us from plugging into the wrong thing. But this high voltage junction box, when we're switching from charging to driving to regenerative braking, all the current goes through there. On this particular vehicle, we have what's called an E-axle. So the motor, it's a permanent magnet electric motor, hooked through some gears directly to the differential. It's a lot more efficient. This truck actually produces about 11,000 foot-pounds of torque, which, if you know anything about torque, that's a lot. We could drag other trucks up and down the parking lot all day. But anyway, this motor is an AC motor, and the batteries that we have are DC. So we have to invert that from DC to AC. We do that through what we call the inverter. It's a little component that sits right up here. And then provides the AC power to the motor. Then when we do regenerative braking, when we let our foot off the accelerator, the motor turns into a generator. If you know that that any motor can become a generator, you just spin it backwards and the current flows the other way. So then we generate AC, it's rectified through the inverter and back into the battery packs, which are right here, providing DC power. So those battery packs, there's 4 of them, two larger ones and 2 smaller ones, about 3,000 pounds of batteries and about 210 kilowatts of electric power. All that is cooled through our battery thermal management systems, that large box on the other side. And then we have another set of cooling loops over here. These are those cooling units that you saw in the crate. So the rearward part is for all the high voltage components. Electronic components can get very, very warm. And so this loop provides cooling for that, and then this loop provides cooling and heating for the cab portion of the truck. This is our high voltage air conditioner compressor. You can see some of those cooling lines that we saw on the spools there earlier. You can see some of the high voltage cables and some of the other 12-volt cables. You know, this wiring harness basically runs the length of the truck. You can see up into the instrument panel area, all the way to the back of the truck. Between lights and controls, from control inputs from the accelerator, from the steering, on the brake, needs to go back to the S box, back to the high voltage junction box. So we have to have wiring harnesses that can transmit those messages and the proper voltage and current through those. So you can see there's a lot of wires on this truck. So wiring harness design is a big thing. Our 12-volt battery is the most important battery on the truck. So it powers all the pumps, all the fans, all the lights, all the control modules, and it is charged through, because this vehicle does not have an alternator or generator like an internal combustion engine. When the vehicle is charging or when it's turned on, this little box up here is what we call the DC to DC converter. And basically it takes high voltage current, steps it down so we can charge the low voltage battery. And once again, all these high voltage components are liquid cooled. So we've got cooling lines running to that. Up front here, you can see kind of the stack of batteries, the 2 smaller batteries, and then the larger battery down here. Power steering pump and all the kind of general truck stuff over here, brakes, steering gear. You can see the leaf springs and the shocks, and then the back of the instrument panel with some of the control modules on it as well. So, you know, once again, a lot of those components are common to all EVs: the onboard charger, the DC to DC, high voltage junction box and inverter, the motors, obviously the batteries are a big one. So, you know, and a lot of times in hybrid vehicles, you've got some kind of onboard generator. Our older vehicles were hybrid vehicles. All the things that we're building now, all of our drones, all of our trucks are all battery electric. So there's no generator on them. A lot of the bigger trucks, the Class 8 semi trucks, have a generator on them to charge the batteries as they're driving.
Great. Yeah. Wow. That is a lot of components on the chassis there. So we do have a couple of questions, Steve, for you. The first one is talking about the frame and the batteries and all the other components that you've talked about. they appear to be very heavy. So one, how much do the trucks weigh? Are the batteries heavy? And then two, does this weight affect how far they can travel?
Okay, these are all great questions. Yeah. So the truck weight is 13,000 pounds. 3,000 of that is batteries. So they are very heavy. One of the things you'll notice is how we have them arranged up towards the front is basically the same weight distribution that you'd see in a internal combustion engine vehicle. So that was an important design engineering factor that we had to take into consideration. What's called a GVW, the gross vehicle weight is 23,000 pounds. So the truck can carry 10,000 pounds of payload. So it's a very heavy duty truck. And what was the last part of the question?
Does the weight affect the range?
Oh, does weight affect the range? Not as much as you'd think. In tests on our previous vehicle, we've noticed that about 75% payload only affected the range on those vehicles by about 4%. The things that really affect your range are, one is highway speeds. These vehicles, just because they're aerodynamic, they're just not really that efficient. They're not designed to do long stretches on the highway. They're really for in-town use, for door-to-door delivery. And then the other thing that happens or that drains the batteries is turning on the heater or the air conditioner if we need to cool the batteries or heat them up. Anytime you change temperature, it takes a lot of energy. So that's one of the things that we're working on to try and get as efficient as possible, so we don't lose range to that, because we know there's trucks that are going to operate in Minnesota and places like that. There's also trucks that are going to operate in Phoenix, where it's 120 degrees out, and how do you cool off your batteries that are sitting about 1.5 feet off of the asphalt that's probably running about 200 degrees. So
right.
And how do you protect all those components? Internal combustion engines and transmissions have a lot of wear items that'll eventually wear out. There's mechanical movement there. High voltage electronic components really don't wear out, and as long as they don't overheat, they should pretty much last forever. Our motors are permanent magnet electric motors. And realistically, we could take them off this truck. Once this truck is kind of done, we could take that motor off and put it on our next truck.
Right.
Replacing a few bearings, something like that.
Okay, great. Yeah. And speaking of the motor, we have a question about how much does the engine weigh?
That's a good question. So we can go ahead and walk back here. So the motor, the motor itself, all this stuff is integral. So I don't know, the individual motor by itself. I would guess, just by looking at it, based on what I know about electric motors, I would say that probably weighs in the range of about 150 to 200 pounds ish. The whole rear axle assembly, motor, gearbox, and then the axles without the tires on them, is about 1,200 pounds. So we actually had one shipped in the other day, and we saw the weight, and I was like, cool, we know that number now. But you can see here, I was talking about the payload of the truck. You can see the heavy duty suspension mounts, the leaf springs, that you're going to see in a larger vehicle. And it provides it's a not quite as comfortable a ride as your car, which is going to be riding on different kinds of springs, coil springs, shock absorbers, those kind of things. So this is really designed to carry a heavy load, and we've done a lot of testing. You can see the difference, the distance from the front wheels to the back wheels, what we call the wheelbase. You can see this part of the chassis. There could be some flex in there. So how do we avoid that? To protect the batteries. If the batteries, flex this way front to back, as opposed to, or twist, a torsion movement, we want to protect the batteries from doing that. So we've done some things with this chassis to make it a lot stronger than previous chassis versions that we've run. And we're actually looking at some of the things that we've done. We're in the patent application process for those. They're very innovative. I'm not aware of any other company that's doing some of these things. And helps lightweight the vehicle, and also provide some structure and support for some of the components on the vehicle as well as being that structure of the chassis.
Okay. So great, thank you. And then our next, we have a couple more questions before we move on to our next part. Denise Johnson wants to know, who is your biggest client that you sell your vehicles to?
So our current vehicle, we're just in the process of getting those out on the road, and we're working on developing a dealer network across the country through our sales team. And our previous vehicles, our first generation vehicles, we've got about 375 of those. The vast majority of those are UPS trucks, and they're still driving those. We've had those on the road almost 7 years now, the older vehicles. And like I said, between all those vehicles, there's almost 10 million miles. And a lot of those are driven daily in the southeast part of the United States, in places like Phoenix, and Texas, and then up in the northwest area, Portland and Seattle. So yeah, we've got trucks all over the country, and we're looking forward to getting, hundreds of more trucks, thousands of more trucks out on the road.
Absolutely. Our final one before we move on is, we have a couple of questions about like how long the truck is and what the dimensions are and the model of the truck. So if you could kind of just tell us a few of those details.
Okay, yeah. So the truck is called a W56, which means it's in the class 5-6 truck class, and that all goes by weight. I'm not going to get too much into the details there, but it's the heavier trucks, but it's not such that you need a CDL for that. That's over 26,000 pounds. So this is below that. The full truck itself is just under 27 feet. It's about 10 feet high and about 8 feet wide. The cubic volume of the body is about 1,000 cubic feet, which is about your typical UPS truck that you see driving around. Those are 1,000 cubic foot trucks. And we have used that convention. Actually, we'll see that here in a minute, that cubic foot convention for the next truck that we're going to see, the W750. But like I said, it's a pretty typical size delivery van that you're going to see. I know somebody had a previous question about the batteries and what happens to the batteries after that we're done with them on these vehicles. And we just decommissioned a whole bunch of vehicles, sold those to a battery repurposing company. Some of those may go to be recycled. We're also working with another company to repurpose the battery. So these battery packs, once they can't charge and discharge at the rate that we need to drive an electric vehicle, they're still perfectly good. They'll still hold a charge. They'll still charge fully up and hold a charge. It just can't charge and discharge at the rate that we need. So we sell those to companies who, maybe they're running some wind generators or some solar, and they can charge very slowly, store the energy here, and when they need it, they can pull it out. So large battery banks, that kind of thing. And there's some things that need to be worked out with that. Different kinds of battery packs. If we send some battery packs and some get some from a Tesla or somebody else, how do you balance all those different battery packs and battery types, voltages, currents, all that kind of stuff. And there's companies working on that. So that is absolutely something we're interested in thinking about. Obviously, right now, these battery packs are brand new, so we're still a ways down the road. But I think by the time these get old enough, that should be a pretty well developed industry.
Great. Yeah, another field for our students to study.
Right.
Great. Thank you so much, Steve. Okay, so we're going to move on from the finished chassis to the 750 truck. But before we do that, we are going to hear from Megan Luster. She's a junior quality engineer at Workhorse.
I'm Megan Luster, and I'm a junior quality engineer. Being able to collaborate with other departments and bringing everyone together to see the project bloom and see the progress that's being made. So I started out building trucks on the line for one of our past projects, and then while I was going to college, and then I got promoted as a quality technician, and then I got promoted as a junior quality engineer. No, I I don't have a degree in quality assurance or anything of the sort. I have a bachelor's of science in legal support. So it has completely nothing to do with what I'm currently doing. I was just motivated, and my work ethic proved to them that, you know, I'd be a great fit for this position. To be flexible and learn time management skills. That is two of the biggest things that I had to learn when I stepped into this role.
All right, thank you, Megan. So the last part of our tour is going to be taking a look at a finished 750 Workhorse delivery truck. So we are back with Steve. And Steve, we probably have about maybe 5 minutes for this, and then we'll ask a few final questions, and that'll be the end of our trip. So take it away.
Great. Yeah, we'll get through this pretty quick. So right now we're here at the staging for the parts for the 750. We've got a 750 over here. You can see it's not got the body on it. They're working on, the next step will be putting on the sides, putting on some of the structural stuff for the body itself. But that's basically what it looks like. We take a cab chassis, we kind of cut away the roof and the driver's door, and then build this out so that it's got an entry like the step van, like our W56. Here's another truck in the next process. You can see the sides are on it. The rear cap, they've done a lot of the wiring up for lights and whatnot. They're still finishing up some of that kind of stuff. Here we go. So this morning when we did our walkthrough, this top was not on this vehicle, so it was sitting right where I'm standing. So they've gone ahead and put the top on, and we're in the process of making sure all these parts fit and all the pieces go together. This area where we're walking through here, this is where the sides will go on the vehicle. So we've got these platforms built for ease of access to some of the manufacturing processes on this W750. So here we have a W750 that's just about done. They're finishing up some of the inside stuff. You see it's got the bumper on it, all the lights, the side panels. Our side panels on this one are a composite as well. The aluminum for light weighting. And then here, once again, you can see the finished front. You can see some of our workers inside doing some of the finishing touches on the interior of this particular vehicle. So like the gray cap on top, that's made out of fiberglass. So we had to have a designer, then we send it to somebody who makes a mold, does the fiberglass and mold of that particular piece. They bring it here and we put it on. So so fiberglass manufacturing. All the rest of the truck is metal. These are obviously plastic molded parts. A lot of plastic on vehicles today. But figuring out what material's best. How is this going to fit the needs of our customers? Is it going to be durable? Is it going to be something that's going to be that's still structural in 15 years? Is this going to be a part that we're going to have available for the lifetime of this truck? One of the things I want to point out here is we do have some of the newer driver safety features. So a side view camera. We haven't quite replaced the side view mirrors yet, but we've got the side view camera. We can also do surround cameras on these vehicles. There's a lot of upfitting that we can do for driver safety. Our idea is, what can we do to make the driver's day easier? What can we do to make the driver's day better? How can we develop this so for ease of use and not just the driver, but also serviceability? How can we make it so that we can reach those components if they do happen to fail or need to be tested? So all that thought goes into it. As we're manufacturing the vehicles, we keep that in mind and make changes when we need to.
Absolutely. So we do have a couple of questions before we move on to our very last interview. What the first one's from William Saunders. He'd like to know, what's the driving range for the 56 and the 750?
Okay, so because the 56 has a much larger battery, it's got 210 kilowatts. This truck is a little under 120 kilowatt hours battery. Both driving ranges are about identical. We're still doing some of the testing on the W56 as far as getting the range numbers, but both of them will do about 150 miles. And some people might go, well, that's not very far. The thing is, for example, one of the major delivery companies, 75% of their routes are under 50 miles. For the Postal Service, 92% of their routes are under 45 miles. So delivery drivers average about 15 miles an hour during their driving day. So you really can't drive that far. To get that whole 150 miles of range out of this thing, you'd have to be driving 10 plus hours. Mm-hmm. So yeah, so the range is really about, and it's about where the industry standard is right now. Most of the other people who are building trucks this size are at about the same range.
Okay, great. And then we also have a question from Robert. He wants to know, what's the cost to build a truck?
The cost to build a truck, besides blood, sweat, and tears.
Yeah.
That's a good question. That is one I'm not really aware of. I know that that some of our prototype parts, some of the parts that we've done prior to the production pieces, 3D printed parts. You can get things like this, hoods built that are 3D printed parts. They can be quite costly. And then when you get into production, there's a mold that's made for this top cap here. And the more pieces, and let's say that mold costs $10,000, just an example. Well, if you run one piece out of that, then that piece costs $10,000. If you run 10,000 pieces out of it, then each one costs $1. So volume is very helpful in pieces like that. Obviously, if we say we're going to buy however many nuts and bolts, and Ford says, well, you know what, we're going to buy 10 times as many. Ford's probably going to get a better deal than we do on nuts and bolts. So, I really don't know the answer to that question, but volume does help. Batteries are still very expensive. But there's a lot of incentives for these vehicles, for both charging infrastructure, what we call the EVSE, the electric vehicle service equipment. That's the wall charger. And for these vehicles, $40,000 to $60,000 per vehicle from the government. Sometimes both state and federal government can piggyback on top of one another. You can what call stack incentives. So you may get 60 from the government, 40 from the state, so you get $100,000 off your truck, right? Which makes it a lot more comparable to a gas truck.
Totally. All right. Thank you, Steve. So we are going to now move on to our last interview. It's with Josh Thornburg. He's a manufacturing engineer, and he's going to talk a little bit about the internship opportunities at Workhorse. And then we'll go back to you, Steve, for some final questions and to wrap up.
I'm Josh Thornburg. I'm a manufacturing engineer at Workhorse. So I went to Union City and I was a class of 2006. I enjoyed a lot of the ag classes, and that's how I knew I grew up on the farm, and hands-on work is kind of what makes sense to me. I would definitely recommend doing what makes you happy, because if you enjoy what you do, it doesn't really matter how much money you make. So this summer we'll be offering internship opportunities for high school. We're also looking at having internship opportunities for college students, specifically in the engineering field.
All right. Thank you so much, Josh. We are out of time, but before we leave, our final question for you, Steve, is what advice would you give to students who are interested in a career in the electric vehicle industry? Oh, and Steve, we're going to have to unmute you. Sorry.
Yep. Okay.
All right,
Yeah,
sorry,
so
start over for us.
No, you're good. Josh put it perfectly. You know, those internships are great. When we were developing our pickup truck, an intern actually did the body design of the pickup truck that we did. So you can learn a lot from those opportunities. You know, I think Tony mentioned asking questions, talking to different people, looking at, you know, what's this person doing, what's that person doing. You know, these field trips. You know, I learned a lot about wind turbines by watching one of the field trips. Very, very, very interesting to me. Not that I'm going to switch careers, you know, but being open to opportunities, asking questions, just learning more, so that you say, well, you know, it's not quite what I want to do. We've got a one of the guys on our drone side. He went from being one of our lead drone pilots to a program manager. Now he's looking at working more kind of on the finance and sales side of the drone program. So, you know, not being afraid to, well, I've only got this degree, so I can't do that. So, yeah, just being open to opportunities as they come about.
Perfect. Thank you so much. And it sounds like there are a lot of opportunities there. It's been really interesting to hear about all of the moving parts that go into just making that one truck. And it seems like there's a lot of opportunities for our students who are watching. So thank you so much, Steve. Our time is up. We are a few minutes over, as a matter of fact. So we want to thank all of our classrooms for participating in our virtual field trip today. We want to thank Steve, Tony, Megan, and Josh, and Workhorse. It was super exciting to be with you, and we enjoyed learning about all the opportunities in electric delivery vehicle manufacturing. So a recording of today's field trip is going to be available on Ohio Energy Project's YouTube channel. And additionally, a link to our post-program survey is going to be provided in a browser tab after the program is over. There's going to be 2 surveys, one for teachers and one for students. Teachers, you can complete the provided survey and forward the student survey to your students if possible. The links are also going to be provided in a follow-up email within 24 hours. Our next virtual field trip is going to be on May 15th at 1 o'clock with the Mid-Ohio Food Bank. Registration is going to be coming soon on our website at www.ohioenergy.org. And a link for registration is also going to be provided in a follow-up email for those who registered for today's VFT. So thank you everyone again, and we hope to see you soon.